Hello, good evening, everyone. Am I audible?
Yes, sir, you are.
Okay,
Yes, sir.
thanks. All right, so welcome to the session. This is the second session for week one, the very first week for our application development course. So as I mentioned before, this sessions on Saturdays will be dedicated to the practical aspect of the course. So the idea of today's session is to cover some numerical concepts. I guess I have mentioned it in the last session also. So we will be going through some numerical part of the week one, wherein you talk about some performance parameters, etc. And this is an important session because it gives you information on various questions that have come in activity, practice, and graded section, and also quizzes. So this will a good concept building session for especially for those who are not from CS background, because this will also clear some jargons related to performance parameters of a web server. Okay. So before we start, is there any question that we can discuss on?
Sir, this is Apul. I could not attend the first session, so I'm not sure if you have answered, but I just want my understanding around project. I'm not getting clear answer. When will it start? When do we have to submit? Because I heard it from some students that they were able to submit it in August, September also, but maybe you can just clarify or you can give some timelines when we can hear more about the project submission.
Okay, so August, September, is it for the last term students?
Last term, yes, sir.
Okay,
yes, sir.
fine. Fine. So generally what happens is we release the problem statement for the project in and around 5 to 6, week 5 or week 6. Okay, but we won't be doing that this term. It will be quite earlier, and you can start off working on it as and when the problem statement is released. We will have sufficient sessions on that, which will give you information on how it is to be done, what are the things required. And before you move on to project, there will be, I guess, 2 to 3 lab assignments you will have already done by then. Okay, so you will have idea on how to go ahead with the project, but at this point, I would say it is quite early stage to talk on anything on the project. Okay, once the question statement is released, we will be taking a separate session on discussion of project. Okay, which will not only consist of explaining you the wireframe, the project statement, what do we expect, okay, how it is to be done, timelines, etc. We will also keep that discussion ongoing from the point the statement is released. Okay.
Okay, sir. Fine. Thanks.
Yeah.
Sir?
So go ahead.
Actually, I'm facing two main problem in week one, that I was not able to understand what is that get and get/server.sh. That thing I did not understood,
Okay.
and something that I'm not where I am facing some problem in latency.
Okay.
Yeah.
Okay, fine. So to answer your first question, get/server.sh, it is something that is related to creating a simple web server, okay, on your Linux machine or Linux Ubuntu terminal or virtual machine, right? So don't have to worry about that much. Second is the latency. So latency, it will be clear after this session, because we'll be talking about it. I mean, in details.
After this session.
Correct. Yeah. So because I'll be discussing on the terms like latency and round trip time, things like that in this session.
Okay.
Okay, just give me the context where you heard this term latency.
On lecture 1.6, I think.
Okay.
Last lecture of this week.
Yeah, last
Performance of your website.
Performance, right? All right. Yeah. So don't worry. I'll be. I'll be taking care of those terms in this session.
Actually, that last lecture was not very clear to us, even after seeing the video.
Okay, fine. Yeah, so that's what. So, this part, the last part of the lecture comprises of the numerical aspect of the course. And not the course exactly, the week 1 content, right? The web server, how setting up is done, distances and etc. So and questions appear every now and then in activity practice sections. So I'll take care that all those questions are dealt with in this session. I mean, as far as the concepts are considered. Okay.
Mm.
Okay, so shall I move ahead?
Yes, sir.
Okay, so I'll be going through some of the questions. So we will, read out the question and start solving those. So that as we solve, we will go through the terminologies one by one, and we'll see. Okay, if there is any doubt after my explanation, you can just go ahead and raise your hand and answer. Ask me the question. Okay, so at this point, I'll just share my screen. Okay, so is my screen visible to everyone? Okay, can you see the Jamboard screen?
Yes, sir.
Yes, sir.
Okay, is the font visible or do I have to zoom it in? See,
Can you zoom it a bit?
okay, give me a minute. Okay, it's fit to 60.
No, 50%. Then. Okay.
It's fine, right? It's visible.
Yeah.
Okay. Yeah, so we'll start off with this question. By the way, I just wanted to know how many of you have gone through all the videos of week 1.
Yes, sir. Done everything except
Okay.
the screencast.
Okay, fine. Anyway, screencasts don't have anything to do with the numerical part, so
Yeah.
that would be fine. Secondly, there is again one more section that we have opened up this time is the, yeah, that's okay. Yeah, so there is one section called as live session, wherein you have been given access or direct, timestamps of the questions that were discussed in previous live sessions, giving you some idea of these concepts. Okay.
Okay, sir.
Yeah, so generally, I mean, if you go through that part, you will see that it was the session that was taken last time. So there was no point in taking it once again because you already have the content. So I just created questions on a step ahead of that, so that so this will give you a sense of what kind of questions you will see in the quizzes. Okay, and I'll try to clear concepts from the basics, and then we will move to the question. Okay, so I have a set of 4 questions, as you can see. This will pretty much cover up everything that is there as far as the numerical part is concerned for a week 1. Later, we will see in week 7 and ahead.
Sir, in this live session, there is this one week 1 Mad 1 open session summary that we do, right?
Correct,
which-
correct. Yeah, so if you see on the leftmost column, you see that, okay, what part is covered in the session. Okay, so it will direct give, and the second column gives you the direct link of that part.
Yeah.
Okay, so some of the questions from activity in practice may have come up, that you may have come across must be easy to understand from that video. I've taken some part from that video also, so that we can talk on that in details. I saw a couple of doubts on discourse based on those questions, so it will be better if we delete it. We discuss it here. Okay, so I'll move ahead. Generally, what I used to do was I would give the question and ask all of you to solve this and post your answers to me directly in the direct chat, right? So there is an option of giving direct answer to me, right? But that was the case when we had a very simple questions, and this has already been done in the live session section, right? So you already have access to those videos. So this time I won't be doing that because this question is like a bunch of 2-3 smaller questions. So I'll directly go with reading out the question and explaining. All right, so as you can see, I'll just read out the question. A set of 2 data centers is located at a distance of 500 kilometers each from the main server and are connected through a cable. Okay, this is important. A client sitting at a distance of 500 kilometers from the main server makes an aerial request whose response data is distributed among the two data centers. Neglecting the processing time at each data center, what will be the minimum time in milliseconds required before the client gets a response? All right. So two things here. Let me just draw the setup and explain the scenario. So what is happening here? I have a main server. I have a main server sitting somewhere. And generally, the data centers are located away from the main servers. So we have two data centers. Data center 1, and similarly we have another data center, that is data center 2. Okay, and then there is a user somewhere here or a client who is making a request to this server. Okay, now what happens, the request that the client is making to the server has a data which is distributed in data center 1 and data center 2. All right, so if the main server has to respond to this client's request, it will first have to retrieve data from both the data centers. Okay, and it cannot proceed unless it has data from both the data centers. Okay, because you cannot send a request that is incomplete, a response to the request that is incomplete, right? So data is required from both the data centers. Now this makes sense. Why? Because in the question it is mentioned that the distance between the main server and the data center is 500 kilometers. In this case, it will not make any difference because both the distances are same. All right. What if the distances were different? Okay. So if let's say if this was 500 kilometer and this was around 900 kilometer, what would have happened? The data from this data center would have been retrieved initially, but still the main server could not have responded to the request of client because the data, the other part of the data was yet to be retrieved from data center 2. All right, so in that case, we have to see what is the larger distance. Okay, now directly jumping on this question will not make sense. Okay, so I'll give us a smaller context, smaller questions. We'll break these questions into multiple parts so that we understand we get the idea. Okay, so what happens is we will just separate out this this scenario and draw a different scenario wherein I have a client and I have a server. This client and this is server, and the data, everything and all, we don't have to. Now this is a composite system consisting of a main server, data center 1, data center 2 separated out from with certain distances. But here the server means server. Okay, so it will have the server, it will have the data. What happens? Client makes a request to the server. This is the request. And based on the request, the server sends the response to the client. So the idea is, what do we need to do? We need to find the minimum time. Same question, right? So same question I'm applying for this scenario. We need to find the time that will be required for the request to go to server and response to reach to the client. Obviously, there will be some time taken by the server to process the request, gather the response and send it to the client, but we are not really bothered about that. So we will just ignore the processing time. Okay. So to find out time, what is required, we may have come across a simple aptitude question, right? Distance is equals to speed into time. All right. So to find out time, we need two other parameters, that is distance and speed. Okay. So that is why we have been given the distances where they are located, or how far the two objects are from each other. So this is where this data serves the purpose of distance. And then again, if you see in the last part, in the bracket, it says speed of light in air is 3 into 10 raised to power 8, and on cable is 2 into 10 raised to power 8. Now, a very, lot of people face this confusion. Speed of light is actually analogous to the speed of signal or speed of data. Okay, so whenever we mention speed of light, it means the speed at which the data packets are traveling. Okay, and then the interpretation of this term, right? So it is 3e8. Okay, this is not 3 into e to the power 8. Okay, this is not. This is 3 into 10 to the power 8. Okay, so you have to interpret this term as this. As you can see, this is e and 8 both together. 8 is not raised to the power of e, right? So this is the interpretation. This interpretation of this term is completely wrong. What you need, how do you need to interpret it? This way. Okay, so before I move ahead, I have some queries on chat. Okay, so I'm getting answers. That's good. Okay, so yeah, so you got the interpretation, right? So this is 3e8 means 3 into 10 raised to power 8. And I mean, some of you will know that the speed of light in air or vacuum is 3 into 10 raised to power 8 meters per second, right? So the same information is given here. And the speed of cable is given. Now, why this is given? Because of this, right? The main server and data centers are connected by cable. So the request and I mean, whatever the data is transferring from data centers to main server will transfer through that cable. And in that case, the speed will be limited by the maximum speed on the cable, right? So it will be 2 into 10 raised to power 8. If nothing is mentioned, if no cable level, nothing is mentioned, you have to take it 3 into 10 raised to power 8 aerial transfer. Otherwise, we explicitly mentioned that what is the medium of transfer. Okay. So the basic of this question is this formula: distance equals to speed into time. Okay, that is what we need to do.
So, sir, in this
Now,
whole question, this formula distance equal to speed into time will be used. Otherwise, we can't find out this minimum time, right? Without using this formula, we can't go
no,
ahead.
no, we cannot, because this is the the fundamental formula or fundamental relation between distance, speed, and time.
Okay.
Right. I mean, there can be multiple ways in which you can calculate time, but it depends on context, right? So what is given in the question, we'll have to take that. Okay. And I mean, now the whatever I said for now, I mean, about the context, it is more related to the physics. So we are not bothered about that. We are into computer organization, computer working. So we will use only this. Okay. Just wanted to give explanation of what speed of light means. Why are the distances given? Okay. So this becomes a very simple scenario, right? What if the distance between the server and the client is 1000 kilometers? Okay. So what we'll have to do? We'll have to find the time for the request. Okay. Time for the request. It will be distance by yeah.
Distance
so this is
by
15 kilometer, I think. Client and main server distance between.
This one,
1500
right? No,
kilometers.
that's okay. I'm not talking about the question. I'm just talking about this scenario, this
Okay,
specific
sorry,
scenario.
sir.
Okay, so yeah, just wanted. So once we understand this, we can move to this picture. All right. So here, the time for the request is actually the distance divided by the speed. Okay, so I'll just write it here. It is 1000, and then we have speed, which is now again. If now for this scenario, nothing is given, right? So we will consider the air. Okay, so it is 3 into 10 raised to power 8. Now, one issue here, the speed is, the speed that we are having is meters per second. Okay, unit of speed. But the unit of distance is kilometers. So we need to either convert this into kilometers per second or either convert these distance into meters. Okay, so we know the conversion, right? 1000 or 1 kilometer equals to 10 raised to power 3 meters, right? So this will give us the time taken by the request to reach from client to the server. Okay, so it will be around, okay, so 1000, and this is 10 raised to power 6 and 10 raised to power 8. Okay, so it is
1 by 3000.
1 by 3 into 10 raised to power minus 2, right?
No,
Seconds.
it will be 2.
So minus 2, right? Because 8 is in the denominator.
Okay, you have shifted it to okay. 10 raised to power minus 2.
So 10 raised to power minus 2 seconds. And I mean, this is pretty intuitive. Why? Because the time considering the speed of light, the time should be in milliseconds, right? It should be very less. The
Okay.
time that we are finding out in seconds, right? So it should be very, very less number of seconds. Okay, that is the reason generally for signals and systems, the time is calculated in milliseconds, microseconds, nothing about that.
So, sir, this unit is given in the question, so we can get answer in this milliseconds, right?
Correct, correct. Yeah.
Because it is given, so we don't have to.
Yeah, so there will be two scenarios. One
unit
is
conversion.
correct. There will be two scenarios. One is when you have options given. So options give you an idea of in what unit you want the answer, or we are expecting answers, right? But if the question is NAT, I mean, you just have to type in the answer. We will be giving this specifically.
Okay.
Okay, so then you have to manipulate accordingly. If the answer was, I mean, if we were asking the questions only in seconds, the answer would have been this. Okay, but you need to convert this seconds into milliseconds.
Okay.
So the unit to answer will be mentioned in the question, right?
Yeah.
Okay.
In either case, it will be mentioned. I mean,
but in not all scenarios, right? It won't be mentioned. I mean, not in all cases it won't be mentioned. In some cases.
Yeah, correct. But the thing is, we try to keep the question generalized. I mean, it doesn't have to be the type of question. So we generally give the required unit.
Okay.
Okay, we generally do that.
Excuse me, sir.
Yeah.
So, is it true like data center itself consists servers, like multiple servers? Or what is the difference between servers or data centers? Like
server, okay. So if you are a bit familiar with MVC, okay.
Yes.
I mean, definitely not into detail, but okay. If you're familiar with MVC, consider in this scenario, your main server is consisting of controller, okay, and your data centers are consisting of model.
Okay.
Okay. In this scenario, entire MVC lies within server.
So, how did servers are interact? How servers interacts with data center? Like, do we have some kind of a logical level or something?
Yeah, definitely. I mean, see, at this point, we will go into the integrated circuit level, right? So we have some data. It has to be processed, converted to binary, sent through the transmission medium, whatever is there.
Okay.
Okay, so that is why we are not bothered about what is happening within the main server. Okay, we are just talking about the distances, how the data is traveling, what is the medium. That's it.
Okay. Thank you.
Okay, that is the reason I said you have to neglect the processing time.
Oh, so processing time includes the time taken by the server to collect the data from the data center.
No, processing time. See, if the information is quite farther from the actual data center. I mean, if the data centers, from the main server, if the data centers are quite farther from the main servers, we will have to consider the time taken to retrieve the data. Okay, but if the server, if I call this as server and I say that even the data centers are within the server, this will be neglected.
Okay, got it.
In case it was different, will it be the larger distance that will be considered in the first scenario?
Yeah, definitely. That's what I mentioned, right? So if the distance was 500 and 900, and as I said, the data required by the client is distributed between the two data centers. All right. So to get the actual response, the complete response, the client will anyway have to take this 900 into consideration. Because what will happen? Yeah.
I mean, why 900 kilometers?
Okay. Let's say there is a piece of information.
Okay.
Okay, this piece of information is to be transferred as a response, right? This is the response. Okay, now this response has to be transferred from main server to client. Okay, now of this response, this part, this was with data center 1. Okay, and this part was with data center 2. In 500 kilometers and 900 kilometers, where do you think the information will be retrieved first?
500,
right? So what will happen? The information from data center 1 will be retrieved, but is that the complete information?
No.
No, right?
Okay.
So to get the complete information, it will again, it will have to wait another some time so that the information from data center 2 also comes in. Okay, it will process the information, make it a complete response and send it to the client. So ultimately, how long will the server wait? Till the time it covers the 900 kilometer and not the 500.
Okay.
Excuse me,
So it's because it's happening parallelly.
Parallelly, definitely. If it is
Others,
happening
sir,
one by
एक-
one,
एक question है इसमें.
go ahead.
So how this 1,000 kilometer is coming in?
Yeah, this is just an example. Okay, 1500.
Yeah, it's 1,500, correct.
Okay, this
No,
was just
that
an
was just
example.
an example, nothing to do with the boxing.
Okay, I wanted to explain this. Okay, before we manipulate with the distances, I wanted to explain what exactly is the distance here. Okay, so the 1,000 kilometer was just I haven't solved this question yet.
So like
Right.
even if the data, the response that we are looking, if it was not split into the two data centers, it would be like if it was in data center 2, then data center 1 would have to be traversed first, and then it's not there. You'll have to at least spend the time required for data to come from data center 2. So 900 that is why maybe the higher kilometers is taken.
Yeah, that's right. So let's say we need some 100 milliseconds from data center 1 and you need 200 milliseconds from data center 2. Main server can only send the response back to the client unless and until it has the complete response, complete data. Okay, so it will anyway have to wait this 100 millisecond and 100 milliseconds more.
Yes.
Right. So ultimately, it will have to wait. To the time taken by the farther data center, right? In our question, 500 kilometers was the distance for both, so it does not make any difference. But you might be asked questions on different distances.
So whichever distance is larger, that will be,
in short. Yeah, in short, whichever distance is larger. See, if I say, okay, whichever distance is larger, you have to take, okay, question, you'll get the answer, but you don't get the essence of that, why we are taking the larger one. This is just to explain. At the end of the day, we want to take the larger one. Why we are taking larger one? Because ultimately we have to send the entire response. An entire response is, a response is complete response only after it receives data from both the data centers. Why? Because I've mentioned in the question, the response data is distributed among the two data centers. What is the distribution? We are not really bothered. Even if it is a very tiny part that is need to be retrieved from data center 2, it will have to wait. Right?
So as a unit of time, how to differentiate from millisecond to microsecond if ms is given like as an abbreviation?
No, ms will never be given. It is millisecond, right? That's why we have given this.
No, but in lecture it is given that in milliseconds the time is given for speed of, for some unit, some
in practice
parameter.
questions and graded questions, it is given in ms. So
ms everywhere.
Millisecond or microsecond, and how to
So
differentiate.
what millisecond is 10 to the power minus.
Okay, fine. All right. So see, you will have to consider it millisecond only. Okay. MS is millisecond because microsecond we generally write like
mus. That's what I was saying.
Okay, but yeah, so we won't go into that much intricacies of units. Wherever it is required, I'll mention. Okay, but
And
MS
just
is
for
milliseconds
definition purpose,
mostly.
sorry. Just for the definition purpose, milli and micro, since micro
Correct.
is also
I'll show you. So 1 second is equals to 1000 milliseconds. Okay. Sorry, my screen ends there. 1 second equals to 1000 millisecond.
Okay.
And it is also equals to 10 raised to power 6 microsecond. Okay, and with that we can say that 1 millisecond equals to 10 raised to power 3 microsecond.
Got it.
So sir, 1 second is 10 raised to power 3 milliseconds.
Yeah.
And 1 millisecond is 10 to the power 3.
Yeah, 1 millisecond is 10 raised to power 3 microsecond.
Sir, if we do,
1
sir,
second is 1000 millisecond.
Correct.
just a second. But sir, if we go with, in negative power, then 10 to the power minus 3, then it will be.
Okay, where do you want to go? Oh, so this one. Okay, see, 10 raised to power. Okay, so you consider it this way: 1 by 3 into 10 raised to power 2. So it is 1 by 300. It will never go in negative. It will be between 0 to 1.
Time will
because
be,
it is time, right? It cannot go in negative.
okay.
1 by 300 is, okay, let me calculate that.
1 by 300.
It will be 0.03 something. 0.003. So yeah, so it is 3.3 milliseconds. Right?
Yeah.
Okay, let me just go to the conversion. Okay. So we have 4 questions. All right. So see, I'll say 1 second equals to 1000 millisecond. Okay. This implies 1 millisecond equals to 10 raised to power minus 3 seconds. Okay. And 1 millisecond, let's not go to millisecond now. 1 microsecond equals to 10 raised to power minus 6 seconds.
Minus 6. Okay.
Yeah. It will keep on increasing with the power of 3.
Okay.
Okay. I mean 1000, 1000, 1000 like that.
Also.
Okay, got it?
Okay.
Okay, so let me go back to the question. Okay, so just erasing is the toughest part.
So you can clear the frame.
Yeah, but I don't want to clear this part. Wait.
So is it possible to send an aerial request to server in real life?
Sorry. Aerial request to server when?
In a real life condition?
Yeah, you are doing it now.
1 microsecond was, sir, how many seconds?
10 raised to power minus 6. I'll give the note, don't worry. I'll give the all conversions.
Okay.
Yeah.
In the exam? Like
Okay, if it is
we
required,
used to get in stats.
Yeah. If it is required, we'll definitely do. That's fine.
Stats was a.
Okay, just let me erase that.
Andrew sir was in stats. Andrew sir was like, you don't have to remember anything. We will give everything.
Not everything.
Yeah.
But,
So all right,
yeah,
no issues. We'll give this convergence because see, anywhere convergence are only to give you the answer, but unless and until you know the formula as in concept, because see in the question that would come in quiz or anywhere, we will be just twisting and turning this statements. That's all. Ultimately, it comes down to this thing.
Okay. So these problem sums are they most difficult, or we can get the logic easily if we have enough practice?
Yeah, this is the simpler one. Anyway, if you get the concept, what we need to do, I mean, all the questions are easy. Just the wordings you need to understand very, and I mean, one thing that most people tend to commit mistakes is convergence units.
That is the issue.
Okay, so I'll also delete this one because we will now go to the finding the actual answer. Every time, whatever, I mean, mostly in numerical questions, you will have to match the dimensions. That is, match the units. If something is there, even in the solving itself, in the expression itself, I'll just show you.
Sir, if we have to just put the answer, just a figure, then it's not need. But if it is a MCQ or MSQ type question, then you have to keep care of the unit conversion, right?
Mostly when it is a numerical answer. Okay, because
Okay.
we mention what is required. I mean, what answers are acceptable. See, if I say 1000 seconds, sorry, 1000 millisecond
Mhm.
and 1 second, both are same, right? But in numerical answer type, either you will enter 1000 or you will enter 1. Okay, if you're asking question, I mean, if you're asking the answers to be in millisecond, and if you put 1, it becomes wrong, even though everything was correct.
Okay.
Right, because we are expecting answer in millisecond, so a number 1000 is configured, right? And you're putting in 1, but that corresponds to second, because you won't be able to put 1 and then second. You will be only putting in value.
Value.
Okay, so what unit is being asked is something that is really important. Okay, so you understood the time taken for the request from the client to main server. Okay, now if this part wasn't there, I mean, I'm going back to the previous example, the example that I took just to explain. Okay, what will happen? The response will go back to the client. Okay, will the distance change?
No.
No, right?
No,
the
sir.
distance which was, let's say, 1500 kilometers initially will remain 1500 kilometers. Okay, will the speed change?
No.
Unless and until the medium changes, the speed won't change.
Yeah.
Right. So, I mean, if the client and main server are connected aerially, the speed of light, I mean, the speed at which the data is getting transferred and the distance between the client and the server will not change. Okay. So, the time taken for the request to go from client to server will be equal to the time taken by the response to reach from server to the client, right?
Yes, sir.
Time taken by the request will be equal to time taken by the response.
Yes, sir. Yes, sir. 3000 by 3 we'll do straight away from here.
Correct. Right. So either you find the final answer and get it multiplied by 2, or you consider a distance double. Why? Because for going and coming, we're not really bothered about what content is getting transferred. Right. Is this clear?
Yes, sir.
Yes, sir.
Okay. So with this, we introduce one more term. If a request is moving from client to server and a response is getting back from server to client, we call it a request response cycle. Okay, request response cycle. And the time taken for a request response cycle is called a round trip time. Okay, round trip time. So if somebody asks you, okay, this is the data center, sorry, this is the client, this is the server, this is the distance, this is the medium of transfer, what is the round trip time? Okay, if the distance was 1000, you will not take 1000, you will take 2000. You're getting, right? Round trip time, the distance will double. Why? Because you will have to take time from client to server and then from server back to client. This is round trip time. For round trip time is the time taken for the response to go from, sorry, for the request to go from client to server and from server to back to client, the response, right? So that is called as round trip time. So here, if you see, neglecting the processing time at each data center, what will be the minimum time required before the client gets a response? So what time are we talking about? Single time or the round trip time here?
Single time.
Round trip time, including the data transfer from data centers as well.
Correct, right? So we're talking about round trip time. Because what will be the minimum time required before the client gets a response, right? Client will only get a response if he has made a request.
Okay.
So first the response has to be initiated from client, get processed at the server, and then reach back to the client. Okay. So if I'm talking about response in any case, it will be the round trip time. If I'm talking, If I'm talking only about the what is the time required by the request to reach from client to server, then it is single direction. If I'm talking about what is the time required for the response to come back to the client, it will not be only from server to client. It will be, I mean, the complete circle. Okay.
Okay.
So here we are asking you the round trip time.
Sir, can I just copy this question?
I will give the session is being recorded, one thing. Secondly, I'll give a printed solution for this question, for all the questions.
Okay.
Okay, so I mean, at this point you can solve or discuss, but if in copying you might miss one or two things, right?
Okay.
I'll give the complete solved PDF for this.
So
Sir, while calculating the RTT, we will consider the distance between main server and data center also twice. Because
yeah,
that
everything.
is also
See what will happen. What will happen? Client makes a now I'll give the cycle. I mean, what is happening? Okay, so request initiated from the client. Okay, so request is initiated from the client. Request is going to the main server. Some processing goes on. I mean, main server understands what is the request. Then the main server understand. Okay, the response for the for this particular client is distributed among the data centers. So for the response, I mean, for the data to come back to the server will have to first make request to the data centers. Okay, so this both will go parallelly.
Sir, and I have one more doubt, sir. If whatever the data it is required, if it is in data center one itself, whatever client required is in there in data center one itself. So it not required to wait for data center.
No, it doesn't have to. Doesn't have to. So that's why this distributed among the data centers makes the difference, right?
Right. So
even if it had to. Even if it had to wait, since the distance of both the data centers is same as 500 kilometer each, it doesn't make any difference, because had it been distributed in data center 1 and 2, then also it will take round trip of 1000 kilometer, 500 plus 500.
Correct. So yeah, that's what it won't make any difference in this case.
Even if it was not distributed, then also it will take that much time only.
That much time, yeah. Why? Because the data centers are I mean same distances, right? So having data distributed between the data centers or having the entire data situated only at one data center is one and the same thing.
So sir, from server, so the two parallel requests will go, right? One will
Server will make parallel requests. So for this it will go, data will come back from data center to server. Okay, similarly from this server to the data center 2, the request will go and data will come back from data center 2 to server. Okay, so one distance is this 1500. Okay, so this is client, this is server. Then the server makes a request to both the data centers. So one distance is this 500 kilometers and second is this 500 kilometers. Then the data comes from data center back to server. So this is 500 kilometers and this is 500 kilometers. I'll just give the arrow so that you understand which one is request and which one is response. Once the complete data is back, with the server, it will merge it, whatever it does, and then it will send it back to the client, right? So this is response. So the total distance traveled is 1500 plus 500 plus 500 plus 500 plus 500 plus 1500. The only thing is these two 500 and these two 500 are happening parallel, so you don't have to consider it twice, right?
Yes.
Correct. So the total distance traveled is 1500, 1000, and again 1500. So it is 3000 and 1000, right?
4000.
Yeah, 4000 is the total distance traveled. But why am I not writing it together as 4000? Because this 3000, correct. This 3000 distance is traveled in air, and this 1000 distance is traveled on the cable. Okay, so the time taken in air will not be equal to time taken in cable. It is greater or less, we are not really sure about that for now. but it will not be equal. Getting? Is this clear?
So this 1,000 kilometers distance traveled through cable.
Through cable, yeah. Both the data centers, right?
Both the data center. And so this, as these two are parallel and they have the same distance, it is going in parallel. I mean,
yeah. So see, I made these two lines, right? So this, I mean, this process and this process is happening simultaneously. So the time is not getting added, right?
Time is not getting added. Why, sir? Because it's.
I mean, let's say you and me start at the same time, and we are going to same place, and we start at the same time. Okay, you take 5 minutes. I also take 5 minutes. Will the total time be 10 minutes?
Yeah.
Or it will be 5 minutes. Because we started at the same time. So will it be 5 minutes or 10 minutes?
5 minutes, sir.
5 minutes, right? So that's why we are not, you take 5 minutes individually, I take 5 minutes individually, that is okay. But we both are starting at the same time and reaching at the same time. So why to count time twice?
Okay.
Right? That's why, yeah. Sure. So, I mean, this is something you have to consider. From the main server, I mean, from the main server, if any request is being made to n number of data centers, all will happen in parallel. Okay, now what makes the difference? If I take 5 minutes and you take 10 minutes, the time will be not 15, not 5, it will be 10.
Okay.
The larger one. Because I took 5 minutes, I already reached, I waited for 5 minutes for you to come.
So in total 10 minutes.
Yeah, because parallel, it is happening parallel. Getting it? Okay. So, yeah, so I could have written everything together. The only thing is the mediums are different. Okay. So that's why we'll calculate time individually and then add it. Okay, so the total time taken by the request is time taken for the aerial request. I mean, this is RTT, both are RTT, right? Time taken aerial RTT and RTT on the cable.
Yes.
Right? Okay. So now we'll just calculate. Let me just add a new slide because. Okay, so the total time will be, first I'll calculate T air, which is nothing but 3000 kilometers, right? So this kilometers have to be converted into meters. So I'll again multiply it with 1000. And then it is 3 into 10 raised to power 8. Any doubt here?
No.
Okay, so this calculates up to
3 into
10 milliseconds.
3 into 10 power 6, na?
No, 8. Why 6?
Okay, right, sir.
8, right? 3,
right.
8.
So it is how much? 1 by 3.
So it comes out, I mean, this comes out to 10 raised to power minus 2 seconds, right?
0.001.
Right. That's what. So I wrote 10 milliseconds. Yeah. See, if I am to write 1 millisecond in terms of second, it will be 0.001 second. This is 1 millisecond written in terms of second. Okay. What is our answer? 0.01. 10 raised to power minus 2.
Yeah.
Right. So, I mean, 0.01 second. If I'm to convert this second to millisecond, what will I do? 0.01 into 10 raised to power 3. Right, millisecond.
Okay.
Converted second to millisecond.
Second to millisecond. Okay.
So this comes out to be 10 milliseconds.
Yes.
Right. So, I mean, finally, what I wrote 10 raised to power minus 2, I wrote this as 10 milliseconds. Okay. So this is the total time taken aerially. I mean, for this part. This part.
Yeah.
Okay.
From client to main server. Yeah.
Okay. Now we will go to
Cable.
the cable part. So the cable part is 1000 kilometers into 10 raised to power 3 because we want to convert it into meters, and then the speed. It's 10 raised to power 2 into 10 raised to power 8. So this comes down to 6 1 by 2. So is it 5 milliseconds?
Correct.
I'm randomly writing. Just want to confirm. Is it 5 milliseconds? Is it coming like that?
Yes, sir. 5
yes, yes.
milliseconds.
Right. So
Yes.
5 milliseconds, right? So the total time would be
0.01 5 millisecond plus 10 millisecond equals to 15
will be
milliseconds.
15 milliseconds. Right. Now, how this will happen? What will happen initially? We'll see. So let me go back here. So here, what will happen? First, it will take 5 milliseconds for the request from client to server. 5 milliseconds, right? Then from server to one data center, it will take 2.5 milliseconds. Okay. Then data will go back from data center to server. So it will take 2.5 milliseconds. Okay. So this 2.5 and 2.5 becomes 5, which is happening parallelly with both. So it will be only 5.
Okay.
Okay. And then once the data is reached here, it will again take 5 milliseconds.
So that is equal to 10 plus 5, 15. Yes.
Right. So this is how the time will be happening. First, request in air, then request in cable, then response in cable, then response in air.
Okay.
Right. So the chronology would be request in air, then request in cable, then response in cable, then response in air. So this is 5, 2.5, 2.55. Total comes down to 15 milliseconds, right? Clear, everyone? Any doubt?
Yes.
Okay, so I saw, variations of question 12.5, 15, 15.5, 20, 30. Okay, fine. So I hope this is okay, right?
Okay.
Yeah, so see, at this point, you might feel that this question is okay, related to maths and not really related to web development. But see, something you have to understand regarding the structure also, right? Some basics of architecture is required.
Yes.
Okay? And some for some things we require time, so we require time. So cannot help with that. Okay, so I'll move to the another part of this question. I mean, the second question that I had was just a build-up of this question. Okay, so see, from the previous question, we saw that 15 milliseconds are required for the entire complete RTT, whatever was the path it was following, wherever it was going, whatever request, response, everything was made, it took 15 milliseconds. That is okay. Now, the question is, how many such requests can be made per second, right? So, a single request, one request requires 15 millisecond. Okay, one request requires 15 millisecond. So, how many such requests can be made in 1 second? Right? This is the question. How many such requests can be made per second? Now, this per second now is important because, as you all know, you count your speed, you calculate your speed, your net is working, net is not working. Everything comes down to something per second, right? So it becomes very important to understand a performance parameter in terms of what is happening per second. Okay. We go on to terms like bandwidth, right? So you may have heard terms like 64 kbps, 15 mbps, 20 mbps. So what is ps per second? So it is a good pointer which gives us an idea of what is happening or what is the status of our connection. Okay, so that is what we need to do. So This is a simple calculation, right? Simple mathematics. So what we need to do, the number that we have to find is seconds, that is 1 second, divided by the time taken for each, right? So it is 15 milliseconds, right? So can anybody calculate this? To simplify, we can say that it is 1000.
1 by 0.015 seconds.
See, we are finding number of requests required. So number can be 3, 4, 5. It cannot be some seconds, right? A number, right? It is a quantity. It cannot be in seconds. So if you see here, if I converted this second to millisecond, it becomes 1000, right? 1000 millisecond divided by 15 milliseconds. Millisecond gets cancelled. Right, okay. This is dimension cancelling. Okay, so it will be unitless.
0.67.
Yeah, so 66.
0.67.
0.67, right? So 66.67 such a request can be made per second, right? Now the thing is, somebody might argue 66.67. How can a number be in fraction?
So requests are a whole number, right?
That's what.
Whatever we request we
So
make.
that's the same as
66 will be the answer.
Yeah,
because the last of 0.67 is not completing in that 1 second.
That's what. Yeah, so that's what. So I mean, see, whenever such question comes in, for the calculation basis, you write this entire term, right? 66.67. Okay, but the practical understanding of that would be you complete 66 such requests under 1 second. I mean there will be some time left for this 0.67 request, right? Consider 0.67 a request. Practically it won't be possible. It is a half request, but consider this to be a request. So some time will be taken, will be required. That will be less than second. 66 request will require less than 1 second, right? The final 67th one will, get overbound, right? Will increase with 1 second. The time taken for the 67th request and the response to come back would exceed 1 second. Okay. Right? So how many total requests are possible? 66, right? You definitely, you go to the lower bound always.
Always you have to go lower bound, right?
Yeah. Practically, if you have to give the actual answer, it should be 66. But see, I'm making a commitment here. I'm making a comment here. Whenever such questions come, you go with the fraction. Okay, 66.67. This answer you go with it. Okay.
Not the 66, right?
Yeah. So this is just
it will be mentioned that accurate to the 2 decimal points and these things.
Yeah, it will be mentioned. It will be mentioned. So no, somebody cannot write, okay, since it is a integer, it has to be 66.00 because you wanted to write accurate up to 2. Okay, you have to write this answer only. Whatever comes after dividing this, that is what you have to write. Okay, you don't need to worry about the actual okay, what is practically possible there. It is an exam. You have to give the answer. Okay, just get the content, get the context from this part. Okay, so the answer would be 66. Always go to the lower bound. Because anyway, the 67th request was, maybe it was made, but it was never completed. So we cannot complete, we cannot consider it to be a complete request. Right, so it's like you are searching for something, but you never get the response. So you cannot say that, okay, I made that request. Right? Any questions here?
No, sir.
No, sir.
All right, so you might encounter such questions in your quiz also.
Okay.
All right, next question. Okay, so this is a question on very related term, bandwidth. Okay, and then again we will talk about a different conversion, GB to MB, right? From giga, mega, tera, something like that. This is another conversion. One conversion which we saw was seconds, milliseconds, microseconds, and all. The other conversion would be this. So we will see that also. Okay. So what will happen? I'll just read the question. What is the scenario? Let's see. The bandwidth of a certain network for an entire day is 4 megabits per second. Okay. So one term here, first term that we came across is the bandwidth. Okay. What is bandwidth? Okay. Second thing, value of bandwidth. Okay. What is this 4 Mbps? So it is 4 megabits per second. Okay. Per second is important. Bits is important. It can be anything, but bits and per second is really important. Okay. Why it is important? Bits. For the first 12 hours, the total bandwidth was equally divided among two devices. Okay. So let's say it's like I have an internet connection and I and my friend are using two cell phones and connected to the network. So my device and my friend's device are the two devices connected to the network. All right. In the next 12 hours, the number of devices connected to the network got increased by 2. So what was happening? Initially, I and my friend was connected and this connection was established for 12 hours. Okay. After 12 hours, 2 more of my friends came in and they connected to the network. All right. So the total connected device would be 4, right? Because my network got, connected devices got increased by 2. Initially, there were 2, got increased by 2. So total devices connected are 4. Okay, and this is again important, with all the devices sharing bandwidth equally. It was the case before also, equally divided. Then now when two devices got increased, entire bandwidths are equally shared. Okay, so it's like when initially, okay, I'll come to that. Then what is the amount of data in gigabytes, new term gigabytes, received by the device that was connected throughout the day? Okay, so let's say I have one device. Okay, so device A, device B, C, and D. Device A and B were connected for how much time? Let's say 24 hours, right? And device C and D were connected for 12 hours, right?
Sir, both were connected for 12 hours, right?
Both
means both? A and B were connected for 12 hours. Then the next two devices came in the next 12 hours.
Yeah, so the devices got increased by 2, right?
Yeah.
So the devices that were connected from the very beginning are still connected, right?
Okay.
So let's say
okay.
You got the point, right? So let's say at 12 midnight, I and my friend got connected to the network. Okay, this is midnight. Okay, in the 12 noon, 2 of my friends added. So the devices connected got increased by 2, but we are still connected, right?
Yeah, you are still connected. Yeah, okay.
So by the next midnight, there will be total 4 devices. So here there are 2 devices. This is 2 plus 2, and this is again 2 plus 2. So these devices are connected throughout the day, right? For 24 hours. Got the point, right? And these 2 devices were connected for 12 hours. So the question is, what is the amount of data in gigabyte? Okay, leave the unit for now. Received by the device that was connected throughout the day. So either A or B.
Throughout the day means A or B. Okay.
Right. Now we are not really bothered about which, is it A or is it B? Why? Because at any point, the device were sharing equal data. Initially, when there were only 2 devices, they were sharing equal. Then later on, there were 4 devices, all were sharing equal. So it doesn't matter. The data consumed by A will be equal to data consumed by B.
Okay, throughout the day.
Right. So since they were sharing the bandwidth equal. Okay, so the data consumed by A will be equal to data consumed by B. Data consumed by C will be equal to data consumed by D.
Okay.
Okay. So you got the scenario, right? Now we will talk about the terms that we came across. Bandwidth. So the bandwidth is an understanding of network. How strong is your network? Okay, how strong is your network? So that gives the information of what kind of network. Is it a weak network? Is it a strong network? A 4 megabits per second is a relative term, definitely, because for an household it is an okay bandwidth, but for maybe a factory or something that is a data center, it will be a very less. So it is a relative term, but it gives an information of, okay, what is the network connectivity? How strong was the network connectivity? So what is happening here? With this, we are saying that 4 megabits of data is being received per second. Okay, 4 megabits of data is being received per second. And now we are now see, if we have megabits per second, okay, I can write it like this also. I will, if I multiply it with seconds, I'll get megabits, right? So I can say that this megabits amount of data is consumed in these many seconds. Correct. Simple mathematics. I'm just playing with the units here. Okay, so what will happen? So just we need to find out what was the bandwidth distribution now, which is very simple again. If initially, I mean, see, the network connectivity is 4 megabits per second throughout. It will not change. This means for the first 12 hours, A and B were taking 2 megabits per second and 2 megabits per second.
Okay.
Right? So it was taking 2 megabits per second. It was taking 2 megabits per second. When these two joined, C and D, everyone was again taking equal. So C was taking 1 megabits per second, D was taking 1 megabits per second, and at that point, A and B also were taking 1 megabits per second respectively.
Okay.
Right?
Okay, because it was equal bandwidth, that's why.
Yeah, the bandwidth was distributed equally at any point.
Okay, at any point. So how
Right,
many
so-
devices are connected? The bandwidth will be shared.
Bandwidth will be shared accordingly. Right? So it will be bandwidth. What is the bandwidth with each? Bandwidth for each will be total bandwidth divided by number. For the first 12 hours, it was 2. For the another 12 hours, it was 4. Okay. So the idea is to calculate the data taken by A in first 12 hours, and then again calculate the data taken by again A in next 12 hours and add them. That will be the total data consumed by device A throughout the day. Right?
So we are calculating it for first 12 hours and next 12 hours for each.
Yeah, why? Because the megabits, I mean, the bandwidth is changing, right? The bandwidth changes or changed in the next 12 hours. Initially, it was 2. So these were happy people. They were getting more data per second. But after when, I mean, on the 13th hour, they started getting 1 megabits per second. So their speed got decreased. And that is pretty much practical, right? So if you see so many people connected to the Wi-Fi, your Wi-Fi will definitely go slow.
Yes, sir.
Right. So I mean, this is how we have to calculate. So we'll have to calculate the total data with A for the first 12 hours with the bandwidth it was taking, and similarly for the next 12 hours. Okay. So I will start with A. So first it was taking, so data. Okay, should I will delete this part, right? Sorry for this erasing, it takes a lot of time. Okay, so here I'll write so data with A in the first 12 hours. Okay, so what is the data? What is the data? This is data taken per second. So I'll have to simply multiply this data with the time, right? So it will be 2 megabits per second. Why? Because there are only two devices initially. What is mega? Mega stands for 10 raised to power 6. Okay, 2 into 10 raised to power 6.
6.
So we dealt with mega. What is bits? Okay, bits is, I mean, the binary digit, a single binary digit is bit. Okay, and we have a group of such 8 bits, which we call it as byte, right? So 8 bit or 8 bits is making up a byte.
8
All
bits
right,
equal to 1 byte.
right. So what we need to do, we need to, so this is 2 into 10 raised to power 6. These are total bits because we took care of mega, right? So these are total bits. If I want to convert it into bytes, what I have to do, I have to divide it by 8. Right, because
Sir, can you
bytes,
explain this again? Like why we are doing 2 into 10 to the power 6?
Yeah, so see, I wanted to calculate the data consumed by device A. Okay, for that, what I wanted, so total data, what I wanted, I need to know how long, I mean, I need to know what was the rate of data and how long I was getting the rate of that rate of data. Are you getting this point?
Yes, sir.
To calculate the total data consumed, I need to know 2 things. One is the rate at which I'm getting data. Secondly, rate, that means does not the price per second, how much data I'm getting, right? Multiplied by the total time, right?
Yes,
This
sir.
is analogous to price, right? So if you are having if you got something for 10 rupees, you want to take 10, you have to spend 100 rupees. So total expenditure is 100 rupees. Right, so that is the rate of per unit into number of units. Similarly, rate in our case is with respect to time. So rate you are getting, or data you are getting per second into total number of seconds. Did you get this? Now where does this 2 came? Now 2 came from this number and the total number of devices. So total bandwidth that I was having was 4. Okay, leave out the unit for now. Total I was having 4. I was getting 4 megabits per second. Total, the complete setup, the place.
Yes,
there were 2 devices. So each device was getting how much? 2.
2.
Right? Why? Because it was mentioned that they were equally sharing the data.
Okay.
Right. So I was getting 2. So the data that I was receiving per second is 2 megabits per second. Now I'm trying to understand this 2 megabits per second. It is 2. To remove mega, I mean to take care of mega, I multiplied into 10 raised to power 6. Okay. To take care of bits, because I want to calculate data in gigabytes, right? So I need to take care of bits and bytes relation. So to find the data in bytes, I have to divide it by 8 because 8 bit makes 1 byte. See, 8 bits makes 1 byte. So 1 bit will be equal to 1 by 8 byte.
8 bit byte.
Sorry, you're getting this? And then we have this number 2 into 10 raised to power 6. So 2 into 10 raised to power 6 bit
by 8
will be the same number divided by 8. So that's what I've written here. Okay, simple unitary method and conversion, right? So 2 into 10 raised to power 6 divided by 8. Now I took care of the data. This is the bytes, total bytes I am getting per second. Okay, total bytes I am getting per second. Now I just have to calculate or multiply this bytes into number of seconds. So for number of seconds, what I'll do? 12 hours, right? So 12 hours makes 12 into 60 minutes, right? And 12 into 60 minutes into 60 makes seconds.
6 seconds.
Right? So simply you can say 1 hour will have 3600 seconds. So 12 hour will have 12 into 3600 seconds. That's what I've done. Okay, so this is the data device A would consume in first 12 hours.
12 hours.
Okay, so whatever answer will come, we'll write here. Whatever answer is coming, that is okay. But what will be the unit of this data?
Bits per second.
Bytes per second.
Only bytes. Only bytes. Because we have taken care of per second. We have multiplied in. I see. So this is what I said, right? Megabits per second into seconds will give me only megabits. Similarly, bytes per second into second will give me only bytes.
Byte.
Okay. Now the second part, data consumed by A for the next 12 hours. Same thing, right? Only what will change? The bandwidth. Since the users now got increased by 2, the total users are now 4. 4 megabits getting equally distributed by 4 users, each one will get 1 megabits per second, right? So that is what I have to write. 1 into 10 raised to power 6 divide by 8, and this is happening for how much time? 12 hours.
12 hours.
12 into 60 into 60. Whatever answer I'll get, it will be in byte. Okay, so the final, so what is the amount of data in gigabytes received by the device that was connected throughout the day? This means the addition of these two. Right?
It's asking for what is the amount of data in gigabytes received by the device. Means it can be any of the 4 devices which are connected, right?
No. It can be any of these 2 devices, because any of the device that was connected throughout the day. The later two, the later two devices, device C and D were not connected throughout the day.
Okay.
Okay, and we are not bothered about which one among these two, because both will receive same data.
Yes, sir.
Correct, because for B also it will be 2 for first 12 hours and 1 for next 12 hours. Okay, so the number whatever I'll get will be same for both A and B. So that's why it is more generic throughout the day. Okay, so let us solve this. Did somebody solve this? This is 2, 3. So this 2 goes. So 3 into 3600 into 3 to 10 raised to power 6. Somebody solve this. I will have to use calculator. So it is 3600 into 3 into 10 raised to power 6.
Sir, 86,400 MB. First one.
86,400.
Oh, sorry. You are in bytes.
108 and 3680.
See, you multiply 60 with 60 and then multiply it by 3 and then multiply it by 10 raised to power 6. So what I am getting here is 10800 into 10 raised to power 6.
Yeah, that's correct, sir.
This is in bytes, sir.
Yeah, this is total in byte. Similarly, the other would be 2, 3.
162 into 10 power 8, sir.
The second one you are seeing?
One is 54.
No, it's same.
So here what I'm getting is 5400 into 10 raised to power 6, right?
Yes, sir.
Okay, so let's add these 10800 plus 5400. So it comes down to 16200 into 10 raised to power 6. Is it right?
Yes, sir.
Okay, so the answer would be 16.2 gigabytes. Okay, now I'll show you, now I'll explain why I have written this 16.2 gigabytes. Okay. Okay, just let me take the new page, because I just have to give information on the conversions also. Okay, so the first one, very basic, is 1 byte equals to 8 bits. Okay, 1 byte equals to 8 bits. Now this now very important to know when we have to use bits and when we have to use bytes is is given in the question, right? I want bytes and I was given bits, so this conversion was very important. Okay, so if we write mega bits per second, see when I'm writing small b, I'm reading it as bits. And when I'm writing capital B, I'm reading it as bytes. Okay, and this is the convention that you have to follow in exams also. If it is capital B, it is byte. If it is small b, it is bits.
Okay.
Okay. Now PS is per second. It can change, right? Mega, giga, it can be anything. All right. So 1 byte equals to 8 bits. Next would be one term higher, right? So 1 kilobyte. So here I'm writing capital B. So you have to understand it is byte. It is 1000 bytes. Okay. Now some might have this confusion. I have read 1024. Okay, instead of 1000.
Yes.
So the thing is, one reason would be a good diplomatic one, because calculation becomes easier with 10 raised to power 3. Okay, so therefore we'll have to follow 10 raised to power 3. Second reason is a more practical reason. If you have a 32 GB memory card, do you get to see 32 GB?
No.
Do you get to use 32
No,
GB?
sir.
No, right?
No.
So consider this 24 bits being used there. Okay, so that's why you will be using this relation only.
1000.
But if you see in the question, we have explicitly given take 1 GB equals to 1000 MB.
1000.
So we will ultimately define the
Exam
relation.
also it will be given, right?
Correct.
If
We will
have
be defining the relation, but by any reason, if we miss the, if we miss to give you this type of relation, which we will not, but if we, by any chance, if you miss, you have to use this only 1000, not 1024.
Actually, just wanted to add. I read it somewhere, because this is because of just marketing people did these things in past. Means it was base 10. If we use it is 1000, and if we use with base 2 na 2 raised to 10, then we need to use that 1024.
Yeah, that's what. See why? Because we are talking about bits, right? It is 1 or 0. Okay, so if you go with that manner, 2, 4, 8, 16, you will reach out to 1024, which is I think 2 raised to power 10.
Yeah.
Okay, so that is another thing. So calculation wise, it won't be an issue, because see, if you have options like 10 GB, if you solve, even if with this relation, you will get something like 10.4, 10.6, something like this, which is very close to the actual option, and definitely will not give you options like this. It will be either 10 GB, then 100 GB, 1000 GB. Options will be like this.
Yeah.
You're getting what I said now?
Yeah.
Sorry, can you repeat, sir?
Yeah, so see, what I'm saying is the relation that we have to follow is this for all the calculation, right?
Okay.
Kilo has to be associated with 1000, not 1024. Okay. By any chance, if you forgot that and you use this instead of 1000, you use this. Okay, with 1000, if I was getting 10 GB as answer, I'm writing this randomly. Okay, with 1000, if I was getting 10 GB as answer, with 1024, I will get some 10 point something GB as answer, which will be easy. Which you can say, okay, 10 point something is 10, and you can mark this answer. Okay. If somebody argues that, okay, what if I have these as options, A, B, C, what should I mark? Right? This will not happen. This is what I will say.
Okay.
Options will be framed such that they are far apart from each other, so that even if you use both of the relationships, you will be you'll get an answer closer to the actual answer. Okay.
Difference won't be much.
Yeah. So it will be easy for, even if you calculate with this, you don't have to go back and calculate with this. Okay. Options will be framed in that manner. But to avoid everything, since we have experienced all these things, we will give all the relations that are required explicitly, the way we have given here. Okay. The answer that we are expecting in whatever unit, we will be mentioning that.
Okay.
All right, so that is something you have to take care. All right, so I'll move ahead with these relations.
Yeah.
Okay. So yeah, so then after KB comes 1 MB. 1 MB will be 1000 KB. It will be 1000 KB, 10 raised to power 6 bytes. Okay, then after MB it comes to GB, which is 1000 MB. 1000 MB, which is also equals to 10 raised to power 6 KB, and which is also equals to 10 raised to power 9 bytes. Okay, and then we have 1 TB, that is terabyte. So it will be 1000 GB, which is equals to 10 raised to power 6, 10 raised to power 6, or yeah, correct, 10 raised to power 6 MB, 10 raised to power 9 KB, and 10 raised to power 12 bytes. Okay, so this is something that you have to remember. I mean, remember as in you need to understand what is the conversion. Otherwise, remember you don't have to do. Now, our answer was?
Our answer was 16,200 into 10 raised to
16,200, 10 raised to power 6 bytes.
6 bytes.
16,200, 10 raised to power 6 bytes. So I can say that my answer was 16,200 megabyte.
Okay.
Okay. If I divide it by 1000, I can say 16.2 into 10 raised to power 9 bytes. Right? 16.2 and 10 raised to power 9. I'm converting this to this. Okay. This 6 I've kept as it is. I've divided this 16,200 by 1000. Okay. Dividing it by 1000, I have to multiply this by 1000. So this becomes 10 raised to power 9. Okay. Now, if you see in the table, 1 GB is 10 raised to power 9 bytes. Okay. So this 10 raised to power 9 can be written as 16.2 GB. That's what I've written for. Okay. So it is 16.2 GB.
Okay.
Getting? So,
sir, can you move to the last slide?
This one?
Yeah. Like how you got that last 16,200?
See, so I wanted my answer in gigabytes, right? The total answer that I was getting, this is 16200 into 10 raised to power 6.
Like A, we are multiplying with 2.
Which one?
The first answer, like 18. What's that? 10,800 into 10 to the power 6. We are multiplying with 2.
No.
No, we are not multiplying. We are adding these two.
Adding both.
See,
it's
this was the
it's only for A and B.
No, only A.
Only A. Okay.
Yeah, only A or only B. See, we have to find out the data that was received by any one of the devices. But the condition was the device must be connected. I mean, that should have been connected from the very beginning of the day, from the midnight.
Okay.
From midnight to next midnight, 24 hours.
Okay.
Right. So device A was connected or device B was connected.
Okay.
So
actually, I was calculating for whole. That's the problem. Thank you.
Okay. So we have to calculate only for one device.
Sir, but it is very tricky, sir, that throughout the day, but even these two people also connected for 12 hours, they also got some, for that particular day, they have done.
Yeah, so why is it tricky? See, 16.2 GB is the data that was received by device A and device B. Okay, and this 5, right? 5.4. So if this is 16.2, this is 5.4. So 5.4 GB was received by C and D. So we can even find out for each one. I mean, each A, B, C, D individually.
Okay.
Right. See, if I go to next slide, I'll tell you.
So this was only for A, right?
12 hours
Yeah.
on that day.
Sorry?
This was only for A, right?
This was only for A. See,
Because
A was connected for 24 hours.
Yeah.
Okay. So we found out that it took 16.2 GB. Okay. B was connected for 24 hours with the same specification, with the same connection time. So it will take 16 GB of its own.
Yeah, individual.
C was connected for 12 hours. Okay, so it will take 5.4 GB of its own. Similarly, D was connected for 12 hours and its connection, specification was same as C. So it will take 5.4 GB, right? So the total data that was given for that entire day was 16.2 plus 16.2 plus 5.4 plus 5. Any confusion here?
No, sir. Sir, if we have Wi-Fi connection, then how to check for Mbps? Question has come.
Okay, I haven't checked chat yet. If you have you don't have to check, you have to buy.
No, but
See, the thing is, they generally give you plans. So those plans is something that you have to buy. So they give you like, see, there is not. When they say unlimited data, that does not mean they're talking about bandwidth.
Okay.
Unlimited data means this, what we are getting. This was the total data. You imagine 16, 16, 32, 32.4, 10.8, 32.4, 10.8. Total 34 GB data was taken.
44.
44. 44 GB data was, taken for, so this is there is no bound on the amount of data. There is bound on the speed of data that you are getting per second.
Geo, they give 24 MB megabits.
Not sure.
Yes, I am sure.
Okay, 24 megabits per second, which is a very good speed. It is like 6 times higher than what we were getting now, 4 megabits per second. Okay.
Per user.
Per user, yeah. But then there is a cap on the actual data, 2 GB per day.
Per day.
Right? So you can use this. So with this, it determines that how speedily you will be getting data.
Sir,
so
in a day, this 2 GB will get over very early because the speed is higher, right?
Yeah.
24 Mbps.
Correct. But it depends on your usage, right? So although you are getting a bandwidth,
it will be used. You'll be using 2 GB quickly. You have a maximum capacity of a maximum speed of 24 Mbps, but it's not necessary that you're running with that speed all the time.
All the time.
All the time, because
right?
speed also
for
varies.
the calculation, sake of calculation, we will use this thing, 24 Mbps.
No. Then there will be something called as bandwidth graph. Okay, so it will give you the idea of what was the bandwidth at every hour. Okay, then you will take instantaneous values for every hour. What was the value? Take average of that, add it, and then you will see, okay, this was the data I received. Okay.
Yes.
See, 24 Mbps is your bandwidth. Okay, but doesn't have to browse that much data every time, right? Your device is not browsing that data every time. The situation that we took is a hypothetical where they are completely utilizing their bandwidth continuously for 12 hours and 24 hours. Okay, so you can imagine 16.2 GB. They must be downloading a TV series complete. Right, so that was the thing. It depends. So even if we are using phone on a daily basis, we make calls, we browse somewhere on social media, whatever it is. So it depends on what connection we are getting. And secondly, see, there is one thing called as network bandwidth, and then there is something called as connection bandwidth. So if you're a client, right, you are taking some data from, let's say, some movie website. And then what speed and what data you will get depends on this connection, not what Geo is giving you. That is the maximum bandwidth that you can attain. Are you getting? So if Geo is giving you 24 megabits per second, does not mean that you will keep browsing your data in 24 megabits per second. It depends on the network bandwidth defined for that particular connection. That particular connection meaning the client, that is you, and the server of the application that you're using. Okay, for example, if you are connecting to YouTube, this you may have experienced. Suppose you are connecting to YouTube, network speed is very good. But if you are connecting to something else, network speed won't be that much. Why? Jio is still giving 24 megabits per second. Right? So it depends on, sorry?
Connection speed is slow of that side.
Of that site. So of that site, I mean that server, right? So there the bandwidth between the client and the server defines with what speed you will be getting data. Okay, and maximum data will be the bandwidth of your network provider. If the, let's say YouTube must be having a bandwidth of, let's say, 1 terabits per second, you will never get 1 terabits per second on your phone. Why? Because then you will be limited. So it depends. It is capped by the network provider and the application, web application you are using. It is capped by whichever is the minimum. We also have questions on that later.
Sir, excuse me.
Yeah. Sir, what you were explaining just now, sir?
I was explaining that it was a discussion. I wasn't explaining any concept. I was just saying that even if there is a network bandwidth provided by a network provider, that is, let's say, Jio. So it gives 24 megabits per second, but it does not mean that we keep browsing our data with 24 megabits per second.
Yeah. Okay.
Okay. So what it depends on? It depends on the connection established between you as a client and the application that you're using as the server.
Okay.
Okay. So for example, for that I gave an example of YouTube and some other random site. Okay. So if you open some random site on Google and you open YouTube, you will experience differences in speed.
Yes,
even though you are having a constant bandwidth provided by your network provider, it is a cap. I mean, your device cannot handle a speed, or that network cannot handle a speed more than 24 megabits per second. That is maximum speed that your device will work with, but that is not the constant speed.
Yeah, every time you won't get 24 Mbps for whole day.
Yeah.
Somewhere.
Yeah, so we also got some examples here, fast.com, speedtest.net. Yeah, so these are the examples where you can check your current network speed.
Can you hear me, sir?
Yeah.
So going back to our example, so these 4 users, so this is the maximum data they can receive each.
This is the maximum data they can receive. In our case, this is the data they received, because we are not because we mentioned that they were continuously connected with the same bandwidth.
Right, sir. I mean, in context of the question, so if a server wants to push data over a network with a speed of 4 Mbps, this is the maximum as per the connectivity time. Each, I mean, the server can push over the network. This is the total amount of data.
Yeah.
Is this correct?
This total, just give me a minute. Where was that? The sum of this 44 GB, that was the total data that was pushed by server.
So a server cannot push more than this over this network.
Yeah, because we are limiting it with the bandwidth.
Okay, sir. Thank you.
Bandwidth
Had it been 8 megabits per second, it would have been doubled. So it is limited by the bandwidth.
So, sir, bandwidth decides how much data we are using. I mean, how much the server is pushing the data to us.
Yeah. Network. See, this is a network bandwidth.
Network bandwidth.
There are two things. Network bandwidth defines the, that's what I said, right? By defining or while explaining bandwidth, I said this is the what you can say, this is the connectivity, or this is the quality of connection that you're getting for that particular network and client connection. Right? Network bandwidth, that particular network and bandwidth of that particular network. The other one, 24 megabits per second, that is the service provider band. I mean, we are using Jio. Jio said, okay, you can use up to 24 megabits per second. If you are using a site or I mean any server, if you are connected to any server that has a network bandwidth of, let's say, 32 megabits per second, I won't allow that. You can use up to 24 megabits per second. Okay, so it becomes, I mean, it becomes
like
case to
bottleneck.
case basis. It will change on case to case basis. But in most cases, it will never reach. I mean, most cases we will never reach 24 megabits per second, right? The connection that we're establishing, that particular network will be definitely less than the bandwidth of the service provider.
It's
in
like
maximum
bottleneck.
cases.
Bottleneck.
Sorry.
Like bottleneck.
Sorry, I don't have idea about that. Okay, so I mean, I hope this is clear. I mean, what I was trying to explain with the question.
You are saying bottleneck?
Sorry, I was
Yes,
saying
yes.
Bottleneck. Okay.
That
Okay,
we learned in maths.
Okay, okay. You meaning okay, okay. Got it, got it. Yes, correct. Yeah. So finally, the answer to this question is this, right? 16.2 GB.
GB.
This was the data received by the device that was connected throughout the day.
Okay.
All right. So you can take the screenshot of this page, although I'll be giving the table of
So you will be providing the
conversions.
Conversion.
Yeah, I'll be giving that.
Okay.
Sir, what if it was said in the previous question that the data is mapped to some GB?
Data is mapped to, sorry, didn't get you.
Mapped to some particular amount. What if, then how to solve the question? Previous same question.
Okay, so you're saying that there is an upper bound on data that can be retrieved, right?
Yes, sir. Means
Okay,
for
so
example, 2 GB per day that you said earlier. The same with 2 GB, for example, we consider 2 GB will be allowed only in day for 4 Mbps.
So see, what will happen? You will still find out the individual data taken. Okay. With the bandwidth, you will still find out what is the individual data each device can browse if there was no limit on data. So what was the data? 16.2 GB, 16.2 GB, 5.4 GB, and 5.4 GB. Okay. Right. Then you will now, if you have this extra condition, that consider that each user can only use 5 GB per data or 6 GB per data. Per day, 6 GB data per day. Each user can use only 6 GB per data per day, the way we have currently, right, in Geo or everything, our network connections. So what will happen? Will this be able to use 16.2 GB? No. So the data used by device A will be 6. Data used by the device B will be 6. Data used by device C will be 5.4 only. Why? Because their network bandwidth does not allow.
Yeah,
so how
0.6 GB is remaining.
The 0.6 GB is still remaining. So this will be the final answer.
Okay, thank you, sir.
Right. So in either case, you will have to first find out which one is limiting. Either the data that can be used per day, that is limiting, or the bandwidth is limiting. Getting?
Yes, sir.
Yeah. So here my data is limiting and here my bandwidth is limiting. Okay, let me just write here data, here bandwidth. That's why only C and D could use only 5.4 GBs, whereas A and B could go to their maximum, the data that they can use.
6 GB.
Yeah, and this is pretty intuitive, right? These both fellows were connected right from the midnight. So they were definitely able to use more data.
Okay.
All right. Any other condition? Okay, so this part is clear, but the question is clear, right?
Yes, sir.
Yes.
Okay, so I will move to the last question. Okay, so we are quite concurrent with the time. All right, so this is, I mean, you may have seen a similar question, and the tagging of similar question is also done in the live session section. Okay, so this is something. Now this is something that is related to server specifications. Okay, I am using a system, I have RAM. Okay, but that is not the server specification, that is my local machine specification. Okay, but we are talking about now server specification. Server also has a RAM. Okay, so the question is, a certain video on the web occupies 4 megabytes of memory of the server. So there is a video that takes 4 megabytes. Okay, if the server works with a RAM size of 5 TBs, how many viewers can concurrently view the video? Okay, so what is happening? There is a server. This is a server machine, and there is a RAM. That is the part of the server specification, which specifies the working capability of the server RAM. The size of the RAM is given, that is 5 TB. 5 TB. Okay, and there is a video called as there is a video, don't know what it is, but it is taking 4 megabytes. It is taking 4 megabytes. Now what will happen? There is a user. The user requested for this video to the server. The video will be retrieved from the database, will be played on the RAM and delivered as a response to the user. Okay, how much RAM will be used for this? For example, you are having
4 MB.
If you are having an 8 GB RAM and you are playing a game that requires a 2.5 GB RAM or GB of RAM, when you are playing that game, how much RAM will be required? How much RAM will be utilized? 2.5 GB, right? Because that is the RAM requirement. Okay. Now this is the RAM requirement of this particular video. What happens? At the same time, this user came. This user requested for the same video. But this video cannot go to user, right? Because this user wants to watch that video from the very beginning. Okay, I'm talking in a very layman terms, right? So this user wants to watch that video from the very beginning. So it has to have an independent playing on the RAM. Okay, so this video then will be converted as a response and will go to user. Now this user has complete control over the video, whether to take it forward, backward, pause it, play it. Similarly for user 1. So it will take up individual or separate RAM requirement, separate RAM space on the actual RAM of the server. So what is the RAM used? Plus 4 MB, right? Same.
Same, because the video is same, right?
Video is same. Only that individual user is having their own control and the time of watching the video. Similarly, if I keep on increasing, to what number I can exactly go? This is the question.
So 5 TB converted into MBs by 4 MB.
Correct. End of the question. That is the thing. Okay, so I'll just write, let us convert this to a formula. Okay, so I will say that total RAM space will be a product of size of video multiplied by number of concurrent viewers, right? Now concurrent term is very important. Why? Because let's say this user watched the video and moved back. Will this space be utilized?
So that space will be empty.
No, right? Means this 4 MB which was engaged in the RAM by the user 1 will not be required anymore. So the use of RAM will again go back to 4 MB from 8 MBs, right? Therefore, to keep on repeating the same task on the RAM, we need to use this term concurrent. Then only we will go to some extent that will use up the total 5 TBs of RAM, right? That's why we are saying that how many viewers can concurrently view the video. Okay, so we need to find this number. So this number you have to find. So what I mean, the one who I don't know the name, sorry, but the way you answered is right. So the total RAM divided by the size of the video.
Okay.
All right. So the total RAM is 5 TB.
5 TB.
Can you tell me the conversion of 5 TB into megabytes?
5 into 10 to the power 6.
5 into 10 raised to the power 6 divided by 4. Okay, so what is the answer now? It is 1.25 into
1,25,000.
Yeah, 1.25 into 10 raised to the power 6. Is it 12,50,000? 1,25,000.
1,25,000.
1.25 million. Yeah, 12,50,000.
12,50,000, right? So it will be 12,50,000 concurrent viewers. Right now, okay, let's try to simplify this conversion. This is 5 TB, right? So what was TB in terms of bytes? It was 10 raised to power
10 raised to power 12.
In terms of bytes, right? And what is megabyte in terms of bytes? It is 10 raised to power
6.
So we'll come down to this. Okay. So what was the answer? It was 1.25 million million viewers.
1.25 million.
Yeah, so that would account to 12 lakhs and 50,000 concurrent viewers that can view the video. So very good RAM, right?
Yeah, very good.
And the other question, I mean, the one that is tagged in the live session gives you these two things and ask you what is the RAM requirement.
Sir, which question?
See, so what happens is, I mean, the previous terms live session, right? What we do is, yeah. So what we do is just to give you the context of what happened in the previous terms and some good videos and some actual concept explanation. What we have done is we have tagged those live sessions into small chunks wherein we give the actual context of what this particular video belongs to. And then if you can click the link, you will be redirected to that particular video on the live session. So this, what happens is similar session I had taken in the last term where I took the numerical part, and that was tagged as a live session, which you can see in on your portal in the live session tab.
Yes, sir.
Right. The only thing is the questions that were taken then were quite basic. So what I did was this time I converted what I did. I clubbed 2 or 3 questions into a larger questions and explained those. Right. Okay. So any doubts in this question? Yeah. Yeah. What is speaking?
I was saying that this time the questions were larger. I mean, they were a bit tricky than the previous.
Yeah. So that's what. So you already have the access to those questions. That's why I did not take those same questions.
Okay. You formed these 4 questions, right?
Yeah.
Okay.
Okay, that's live sessions. In the live session drop down menu, that live session is from the previous batch.
Yeah.
Okay.
Yeah. So similar, you will be getting similar taggings for other sessions also. It won't be this numerical every time. It can be some other concepts also. Some questions discussed generally in the open session, something like that.
So, sir, and whatever you discussed today, these questions, we can expect some similar questions in our upcoming quiz also. I mean,
yes.
If not.
Yeah, similar questions.
Similar questions.
Yeah, because ultimately the concept remains same. See, the questions like concurrent viewers will revolve around this formula, right? No matter what the statement is. The questions on bandwidth will revolve around these things, right? Time.
On time.
Right, data per second into number of seconds. The questions on distances will revolve around this. Distance equals to speed into time. So you just have to figure out the scenario, what is happening. Then it remains, then it comes down to the same formula every time.
Okay.
Only these scenarios will change, medium will change. distributions will change.
So, sir, whatever is taught in the last lecture, these sums cover that lecture part, right? I mean, the performance, whatever was taught in the last lecture.
In week 1.
In week
So
1.
correct. So yeah, there was one question in the very beginning of this session. I'm not sure if the same learner is still there. He was saying that I have some issues with latency. Is that clear?
Latency.
Yes, sir.
See, so
I think these are the these things called latency.
Yeah, so I'll just explain with this with the term specifically. So see this question, right? I was getting, I mean, it took 15 milliseconds for one request and response cycle to come back. This means what happened? The point when client made the request, the client had to wait 15 milliseconds to actually see the response. This is the latency of network.
Yeah. The waiting
no
time.
matter what, no matter what, it will take 15 milliseconds every time for every request.
Okay.
So, sir, whatever
so it means latency means the waiting time, sir.
Yeah. Latency is after making the request, how long did the client wait for actually receiving the response?
So, sir, latency doesn't mean with how much time the request is taking to reach to the server. That is not the case, right? With latency.
No, complete.
Means
request to reach to server, get processed and come back. See, one thing here, one thing to mention here, we have only considered the distance of traveling and speed of traveling, not the processing time at every stage. That will add up to the latency. See, that is the reason I'm calling this question, this statement. See, what will be the minimum time? Minimum 15 milliseconds you will have to wait, no matter what. See, at this point, we have neglected every other aspect other than the distance and traveling speed, which are the minimal aspects. Apart from this, there will be requests made by the server, latency by the server, processing time at server, retrieving at data centers, retrieving of data at data centers, making those requests. All those add up to the latency. So your time can be more than 15 milliseconds, but it cannot be less than that. That's why we are calling it minimum time.
Sir, latency means you mean after making request, the time takes to get response.
Yeah. Because if you're not making request, you wait for eternity.
Okay, sir.
Right.
Sir,
from the time you make,
when we ping a server, is this the same time that is calculated?
When we ping the server and the server understanding your ping and making a response, this is the time.
Thank you.
Latency is actually the round trip time.
Latency is the round trip time, right?
Yeah.
Sir.
Yeah.
So could you explain a little bit more about UDP and TCP transfer protocol?
I mean, what do you want to know? The thing is, they are. At this point, I won't be able to give you actual differences, right? But the thing is, they are some form of protocols which we are using every now and then.
Okay.
Okay,
so,
you won't don't have to worry about every protocol in detail. The reason being, we need to get the simple idea of protocols, not the actual specifications of protocols.
Okay, got it, sir. Sir, I have one more doubt. Like, could you explain the different terms associated with a complete URL? Like, I've faced some questions which is asking for the different terms associated with a complete URL.
Okay, okay, got it. At this point, you don't have to worry about it. I'll just let you know. I mean, I'll just show you.
Okay.
Because in the graded,
yeah, that's why I'm
the
asking.
graded question that's was asked.
That's okay. That's okay. The thing is, see, we will be talking about URLs only when we will when we'll start with Flask. So all these things will now, as they sound pretty tricky, but they are very. They will be used so frequently that you won't be, you won't get stuck anywhere. Okay, I'll just show you. So this is, let's say I have this URL. Okay, share this URL.
Okay.
So you have written this randomly, or is it some actually?
It's randomly.
Okay, random. Okay.
Okay, so this is called as protocol.
Okay.
Okay, this is called as protocol. HTTP. We will also be having a look at HTTPS. Okay, so currently, if you see this Jamboard, can you see the link of Jamboard?
Yes, sir.
It is HTTPS, right? But so that is a secured, secured socketed protocol.
Connection.
But we will be secured connection.
Connection.
Okay, so we call this S stand for secure socket. So for that, I mean, these are all protocols. So HTTP is a protocol. So this part says that it is a protocol. Okay, this part is actually the domain name.
Localhost.
Yeah, domain name, or this part also also corresponds to IP address.
Yeah.
Yeah.
Okay, this localhost. This part is called as port.
Port number.
Okay, everything that follows is called as path.
Okay, path.
Okay, then if you from here path starts, right? Now if you go after all the colons, you will keep calling them subpath. Path, subpath, directory, subdirectory. Now there is one more component to a URL. Just give me a minute.
So this home is the main path, right?
Sorry?
This home which you have written is the main path.
Or the path starts from the port number, after the port number. Everything that follows is a path. Now then there is something called as this, right? So okay, so this part, everything that follows question mark, where is the pen? Yeah, everything that follows a question mark is called are called parameters.
Parameters.
Or query string.
Path ends before the question mark, right?
Yes, yes. Path ends before the question mark. And the complete thing, I mean, there can be multiple parameters. This complete thing is called as a query string.
Okay. Query string.
Okay, I can have
after
name,
question.
Surname, after question. Query string starts after question mark.
Okay.
Your path and directory ends at before question mark.
Question mark is the separator.
Yes, yes. Question mark is the separator between the path and the query string. Otherwise, you will have these forward slashes. Now, the thing is, if you have multiple forward slashes, for example, // home, / my courses. So while interpreting this, the browser converts these two into one. Okay. So it does not make sense how many forward slashes you put unless you put something between those forward slashes.
So
then
in the case of HTTP,
the course there was a mention of index.html. Now, is that something mandatory, or that's the main? How is that related?
Yeah. So index.html. This my courses, instead of my courses, you can write index.html. So what is happening here? What is happening in the home directory? You have a file called as index.html, which is being retrieved from the server.
Okay.
See, as I said, this
part,
home.
So this becomes the whole part right up to index.html?
Yes, yes, complete. Absolute path.
Absolute.
So the last component of the path should always be a file name.
It doesn't have to be. See, why? Because
how will you open up? How will you open up? How will the URL know what to open up?
How will they see? What will happen is, so what is happening here? What is happening here? We are trying to call index.html complete file from the server. Okay. We are trying to call index.html from the server. That's why we are going to home/index.html. For example, there can be path. If you go to that path, your your HTML file can be rendered. Okay. For example, if I simply write if I simply write, yeah. So if I simply write this, okay, HTTP localhost 5000 home. What will happen? This URL, this complete URL, HTTP localhost 5000 home, is sufficient enough to invoke or to render HTML, index.html, or whatever HTML file I want to render.
But if there are 2-3 HTML files there, won't it get confused? Or do we need
No,
to
no,
specify
no. We
that
can map that. We can map. I mean, we can map every file to the URL.
Okay, so it's not required to have that index.html.
No, I mean, internally it will have, we don't have.
Okay.
It will understand. See, what happens is, I'm not sure if I have to tell you now, but see, the thing is what happens when we write up the controller, when we create a controller, what we do is we map that controller to a URL. Okay. So whenever we hit that URL, that controller, consider a controller as a function. So in Python, what do you do to call a function? You write the function name and give the curly braces with the parameters if it requires. All right. Right. So that will call the function. In terms of web application, what you do, you hit a URL and that function gets called. Now, if that function, now a function can return something, right? In our case, it will return an HTML file. Did you get this? See, there is a, okay, where is my pen?
And so one more thing, like when we are creating the Python built-in server and creating the HTML document with the name index.html and executing the commands on the command prompt. So in that case, it will show the HTML contents. If somehow we save the HTML file with other name, in that case, it shows the directory of the
Yeah, that is, I mean, that is something which is, have you observed this in Replit?
Yeah, Replit or also using simply command prompt.
Yeah, so see what happens is generally, how do you address a Python file? Main.py, app.py.
Yeah.
Right. So this HTTP server is something. So whenever you call HTTP server, it will search for index.html.
Oh,
okay. It
means
is defined that way.
Okay, index.html is a default option for the server.
Yeah, default name HTML file or default HTML file name which the Python HTTP server searches for whenever you invoke the URL.
Okay.
Okay, can you also tell us about this home path and directory? Because now, supposing where do we create we start building these files, right? So we have to store them somewhere on the disk.
Yeah, correct. So that's what I'm saying. So you have a URL, right? What happens in general Python? What we do, we create a function. Let's say func1, and it takes A and B as parameters. So you define it something like this. Okay, and then there is something, and then you return. Whatever is returned will be assigned to the variable whenever you call it. For example, if I say capital A equals to func 1, 2, whatever is returned will be assigned to this A, right? Correct. This is the case for normal Python function. In case of application development, what we do is we write a URL, we create this function, and then we map it. Okay. So whenever we map this function, whenever we hit this URL, when this URL is hit like this, what will happen? The return the return value, whatever was coming as a return value, in our case, in application development, what will be generally a return value? An HTML file. So when we hit this URL, we will get a response in the form of HTML. Getting this?
Actually, my question was a little different. I mean, my question is the physical storage of the files and the HTML in Replit and all. How do we, specify the location?
That's what. So what happens is
A C drive you have, right? You have C drive, and then within C drive you want to create a project, and then map your functions and URLs to that place, right?
Correct. So let's say C. Okay. When we will be using Flask, we will talk about a folder called as templates. Okay. So all your HTML file will be saved in this templates. Okay. What will happen whenever I hit a URL and I say whenever I hit a URL, you give this file HTML. Okay. Index.html. You give me this file index.html. So what it will do? It will search C/templates/index.html. So physically, you have to store all your HTML files in templates. Okay, which is a default folder that we are going to create when we will work with Flask. For now, when you don't have a framework, when we have Python HTTP server and simple web server, things like that, or an HTML, CSS, JavaScript REPL in a replit, what will happen? There will be only one file index.html stored in the root folder. It will search for index.html and render it. Other than that, it won't be able to render. Okay, but our website doesn't work with single HTML file. So when Flask comes into picture, we will have folders wherein we save the HTML files, wherein we save the CSS and JavaScript files. Okay, so we don't have to specify these paths every time. C templates index.html, C templates index2.html, index3.html, home.html. We don't have to do that. We just have to say into the function render this, and it will search for that file within this template and render it.
Okay. Sir, what is a root domain in a domain name? I encountered a question with this.
Root domain. Yeah, so I mean, see, this is a bit tricky because most, I mean, many other sources give you different answer. Different sources give you different answer. Okay, so let's say we have something like called as www.google.com. Somebody called this as domain name. Somebody called this as root domain. This is somebody called this as subdomain. So there are so many different terminologies that are used. Okay, so I mean, at this point, I'm not sure what to give as a comment. Said, do you call this as a domain? You call this as a subdomain?
Because this was a question in one of the graded assignment. Because there was a option where it was written that http/onlinedegree.com. Online degree was some option was there. It was the root domain, so we couldn't understand what does that mean.
Okay.
It was one of a question.
Okay. Generally, whatever comes up after the protocol, this part, generally call this as root domain.
Not the
this
HTTP one.
No. This is the protocol.
Okay.
Okay. So this is the maximum I can comment on, because see, different resources give different answers on this. Okay. So there is a big debate on this, what to call it as a root domain, subdomain.
Sir, in some of the websites, we don't have this www.
That's what, see.
Can you explain that?
Yeah, that's what. So World Wide Web is just to specify that, okay, it is some using a World Wide Web. For example, sorry. For example, yeah, you see this https mail.google.com.
Yes.
Yeah, so differs.
So
that's why I'm telling you, you call this the second part, no? Everything that follows as the root domain, whatever they are creating them as the root domain, I mean, whatever the company, the application or the designer of this application is telling as the root domain is to be called as root domain.
So it may or may not have the www component.
No, that is not every time required.
In this example, mail.google.com will be the root domain. What will be the path in this case? It is up to the whole inbox?
Complete, yeah. This is the absolute path. There is no parameter, right? Inbox is again a folder.
No, I mean in the URL, if the question comes, specify the path and specify the
yeah. So whatever I have highlighted is the path.
This mail U0 inbox.
Mail /u/0/ / hash inbox. This is
This is
the
the
complete
path.
path.
And mail.google.com is the root domain.
Root domain.
That's also the host name, right?
That's also the host name.
Hosted.
Yeah.
Okay.
Yeah. That's also the host name. If we are using local machine, our host becomes localhost.
Yeah.
So local machine what?
My own system, for example, suppose where was I? Here. Right. So here I gave, right. So if I'm using my own machine, I'm not connecting to any actual server. Connecting to my own server, creating my, I mean, asking my machine to act as a server, using my machine as a client. In that case, this is used, right? Localhost. This localhost is also corresponding to this address 127.0.0.1.
Localhost
Okay.
IP address.
Yeah, there is also something called as this. So this is called as a special special IP address.
Sir, where this is used? Special IP address.
You will mostly see it in Replit.
Oh, in Replit.
Why
This
we
is
are seeing it in
IP4,
Replit? Right? Why we are seeing it in Replit? I'll tell you when we'll use Replit.
Okay.
Then there is an actual IP address, like something called as 192.168. Something. Right? So I think if you can go to CMD and write ipconfig command, you will see your own IP address.
Means our own system IP address.
Yeah, your own system. Go to CMD and write ipconfig.
Just ipconfig.
Yeah.
Nice. Sir, in IP4 address, the numbers are from 0 to 255, right?
Yes, 0 to 255. We will come to that. We will come to IPv4 and IPv6 in the next session.
Okay. Can you talk about the DNS? I think there's also that the IPs are stored in DNS, and when we type a URL, it first goes to the DNS to pick out the IP.
Yeah, that's what. So there is a big tree structure, right? Something called as a DNS, then domain, subdomain, path, like that. That is what I was saying. Different resources talk about differently. So DNS is nothing but domain name system, the way you name the domain.
Domain name system.
Okay, some general information. 192.168.0.1 is the IP of D-Link router. Okay. All right. Fine. Clear?
Yes.
Okay. Any other question?
Sir, I have a query regarding is increase that cast video that Tejas sir prepared. So, sir, he prepared on it. I think Linux-based operating system.
Yeah.
So, but I am using PowerShell terminal. So, I think what my question is that will it be difficult on PowerShell than in Linux or like this one?
Okay. So, what was sir doing with the Linux system? Why did he use the command line there? Can you recall?
He was using for creating a simple Python web server or running the HTML page.
No. Before that, how did he start? Probably creating index.html file, creating directory, creating a new folder. Right? Can you do that in Windows? And by right clicking?
Yes, sir. Yeah.
That's it. Why do you need Ubuntu then?
Sir, in Windows, what do we have to use? What sir is using?
You don't have to use
question also in Windows what to do.
The corresponding commands differ, I think.
Okay, see, so okay, fine. So, all right. So for Windows, if you want to create a directory, use this. Make dir and directory name. Okay, this you have to put in by yourself. Whatever comes in the angle bracket, put in by yourself. Okay, mkdir others. It will create a folder name others. Okay, then for creating a file, just write cd dot give angle and then give the name of file.
Command prompt, no? Command.
Yeah, in command prompt. cd dot closing angle and whatever file you want to others.txt, txt, other.py, other.html, it will create all the files. I think you won't need command more than this. Okay, then there are commands of pip. We will come to that when we will install libraries in our system.
Sir, will you also give held a session for screencast videos, or do we have to
See, what
watch it
happens
on
is,
our own?
no. The thing is, see, screencast becomes tough only if you focus on the Ubuntu part. If you focus on the coding part, it is, it goes in harmony with the live sessions. Okay. So first week, screencast talk about creating web servers and all. First week, live session talks about numericals. We have to cover everything, right? Second week onwards, screencast talks about HTML. Live sessions also talk about HTML. So whatever is being done on the Ubuntu, we will do it on Replit and Windows. So I think that will clear your doubts.
But sir, in this lecture 1.1 screencast, if you have to do whatever sir was doing with Ubuntu system, in Windows we have to use command prompt. Other than this, we have to use any other.
No, see, that's what. So command prompt sir was using only to create some folders and files, right? And the web server, Python HTTP server that we were creating is just for your information. We won't be using that. Okay, so once we have, see, at this point, we will start off with creating simple HTML and CSS files. Okay, it is easy to serve static HTML and CSS file without any server running. Okay, you
Sir,
can simply
but in command
them.
prompts, I'm getting syntax errors, sir, in command prompt if I'm doing that.
What, the one I gave now? For what are you getting syntax error?
In command prompt, I given mkdir and less than, I given some name and close that bracket.
No, you don't have to. Less than and greater than, you don't have to do. This is for your understanding. Okay, try this. Try this.
So what we have to write?
Right.
This is K is small, okay? This K is small. mkdir my underscore folder. It will create a my underscore folder.
Sir.
Similarly with CD also, we don't have to give that angle bracket.
No, with CD you have to give.
Okay,
because this says you have to create a file. I mean, you have to go into current directory, whatever you are there, create a file named others.txt. So here you have to give, here you don't have to give.
Another question about this web server. Do we have to run that web server command within that folder, or we can run it even from anywhere? It should be fine.
In that folder.
Okay. Otherwise, I think it takes the path wherever it has been created from. Right?
Yeah. So in that folder, because the code for your folder, the code for your server is there in that particular directory.
So we create that directory, then run the command within that directory for the Python server.
Yes.
Okay. Yeah, that was one doubt I had.
Yeah, and this is something, if you know, you don't know, because you don't have to worry about it much. When we will work with Flask, Flask has its own server, for creating server, and it doesn't have to, you don't have to worry about the directory and stuff. The server is running, it's running. Things get easier. This is like just introduction. So we do not have, at this point, we do not have tool like Flask. So how to do that otherwise? That is what we are doing. But once we are done with, once we introduce Flask, things get easier.
Sir.
Yeah.
Sir, I have one more doubt. Like, can you discuss about loopback address? Means on the conceptual level, what is it?
I'll come to that. The next session will talk about IPv4 and IPv6 now. So I'll come to that.
Okay.
But you just consider that there is, one understanding can be 127.0.0.1 is called as a loopback address, right? So why do we call it as a loopback address? Because I have a machine, I am the client. Okay. Now client is sending the request to, let's say, this URL, http://localhost/home, and there is also a port number, let's say 5000 and /home. Okay, now this request is going, where is it going actually?
To the same machine?
To the
same machine, so it will have to come back.
Same machine.
So it is looping back to the same machine.
Okay. So, sir, actually, I'm facing the question like we have given different kind of IP addresses, and it is asking for whether it is loop back address or not. So how can I identify like whether it's
all
loop
the
back or
addresses that return the request to the same machine can be called as loopback address. You can understand from this thing, right?
Okay.
And since we're talking about IP address, we wouldn't call localhost as an IP address. This is just a domain, simple domain name or a host name. But 127.0.0.1 is actually an IP address, and which is looping me back to the same machine. So you can call this as a loopback address.
Okay, okay, got it.
Yeah, we'll talk about IPv4, IPv6 in more detail in next session when we will talk about number system in details, right? We might also see one or two conversions.
Sir, after Saturday, is there any session? I mean, next session?
Next session is on Wednesday.
On Wednesday. In the calendar, it's not showing.
Yeah, it will be updated.
Okay, it will be
updated.
Will that cover for week 1 only, or will we be covering something from week 2 also?
No, we'll start with week 2. I mean, that's what. So see, why have I halted this IPv4 and IPv6? Because it requires some understanding of number system, right? Week 2 is more of understanding number system. Okay, so week 2 content would start from there, and then we will start with the actual practical part, right?
So
week 2 content has already been released, right? It must be out.
Yes, it has been.
Correct. So week 2. So every Saturday, as I said, will be a practical session. So we can talk about more of HTML and CSS on next Saturday.
And Wednesdays will be more of a discussion.
Discussion sessions wherein you can ask your doubts or questions and other things.
Sir, it's on Thursday or Wednesday?
Wednesday 6 to 8.
It was, I think, it's a Wednesday.
Yeah. We might have extra sessions also because there are some topics which might require more than 2 hours to cover. Right. So we will have extra sessions for some weeks.
This will be is IST time, is it? India time?
Yeah. 6 p.m.
Yeah, it's India time only. Okay, sir. Thank you.
Okay.
Thank you.
Okay, fine. So with respect to session, this is what I wanted to say. I think that would be it. If there is any other doubt, we'll discuss on it. Otherwise, we can. Let me just stop the screen. Yeah. So if there is any,
Sir, you will share this. Today?
Yeah, I'll share. I'll share. Not absolutely. I mean, just exactly after the session. I'll just.
Okay. Yeah, I will. I
need some time to write it in proper format so that it is understandable to everyone, and then I'll share.
Okay. Sir. Thank you, sir.
Okay, fine then. Thanks everyone. Thanks for joining. We will officially close the session. Yeah. Good night.
Thank you, sir. Good
night.
Thank you, sir. Good night.